C2, Edexcel 2015. Looks like a factor theorem question. It's actually a remainder theorem. This is very similar to factor theorem. I'll explain why. But use it to show that b minus a is 48, and then get another equation involving a and b so that we can find the value of a and b. Also, the second bit of information is that 2x plus 1 is a factor of f of x, and then factorize f of x fully, do the division thing, and get the quadratic factorized. Okay, so remainder theorem is the kind of inverse, the opposite to factor theorem. We know that factor theorem says if f of a is equal to nothing, then x minus a is a factor of f of x. And the remainder theorem says if f of a is not 0, i.e. f of a equals some other number b, then f of x divided by f of a will not be equal to 0, so it will be some other function of x plus a number, and that number is b. So when in a normal situation, look, x minus a is a factor, then f of a would be 0. So we solve the bracket, if you like, equal to 0. So f of minus 1, using the remainder theorem, we can say that's 45. And so when we sub f minus 1 into here, the answer will be 48. So 6 minus 1 cubes plus 3 minus 1 squareds plus a times minus 1 plus a b is equal to 45. Multiplying these out and rearranging, we get minus 6 plus 3, take away an a plus a b equals 45. So take away 3 is 42, add the 6 is 48, minus a plus b equals 45, plus 6 minus 3 equals 48, i.e. b minus a equals 48. And we've done that, show that. Hooray. Given also that 2x plus 1 is a factor of f of x, so down here we'll do part b, then factor theorem says f of minus a half is equal to 0. Solve the bracket equal to 0, 2x plus 1 equals 0, x equals minus half. When we sub minus half into our function, then the value will be 0. So that tells us that 6 lots of minus an eighth, which is minus a half cubed, plus 3 lots of a quarter, which is our minus half squared, plus a times a half, but it's minus a half, plus a b equals nothing. So this is minus 3/4, plus 3/4, take away a by 2, plus b is equal to nothing, get rid of them. So this says b is equal to a of 2, so a equals 2b. So we can sub this back into our other one. So b minus an a, which is minus 2b, equals 48. So b is equal to minus 48. And a is double that. A is equal to minus 96. And part C, factorize fully. So a couple of ways of doing this. My way, fast way, 2x plus 1 is a factor. So write down the factor 3 times because we've got a cubic. So 2x plus 1, 2x plus 1, and 2x plus 1. What do we times 2x by to give 6x cubed? And the answer is 3x squared. That gives us our 6x cubed, and it also gives us 3x squared. And we need 3x squareds. So this bit we don't need. What do we times? Remember, this is minus 96, and this is minus 48. So what do we times this 2x by to give minus 96x? And the answer is minus 48. So f of x we can write as 2x plus 1 plus 3x squared minus 48 times. There's our quadratic factor. And this factorizes. So it's equal, let's take the 3 out. So we've got 3, 2x plus 1 times, divide this by 3, we get 1, x squared, divide this by 3, we get 16, and oh look, it's a difference of 2 squares. So f of x, therefore f of x can be written as 3 lots of 2x plus 1 times x plus 4 times x minus 4. And we know a nice way of checking this, and that's what we should do before we move on to the next question. When we put minus 1 into this, we should get 45. F of minus 1 is equal to 3 lots of 2 minus 1s is minus 1 plus 1 is minus 1. Minus 1 plus 4 is 3. And minus 1 take away 4 is minus 5. 3 times 3 is 9. Minus 1 times minus 5 is plus 5. 9 5s, 45. So that is correct. And the other one, the f of minus half, should be equal to 0. And that was this constraint here. And if we put minus half into this one, we get 3 lots of 2 minus halves. 2 times minus a half, which is 1, plus, sorry, minus 1, plus that 1, that's nothing, times the other 2 is still going to be nothing, so that's correct too.